So, systems of equations. How many of you guys remember systems of equations from Algebra 1, hopefully? Okay, some of us. Good. We're going to get into systems of equations in Algebra 2 as well. How many equations were in each of our systems in Algebra 1? Two, right? Yeah. You had two equations. That was our system of equations. In Algebra 2, we're going to get into systems of equations that have three equations. Before we get into that, we're going to review systems of equations that have two equations, two variables. Okay? So, a system of equations is just a set or collection of equations that you deal with all together at once. We're treating our equations all together at once. So, if we have two equations, that means we're going to have two variables. Our two variables are going to be x and y. So when we move to three equations, how many variables do you think we're going to have? Three. We'll have x, y, and z that we'll have to solve for. Okay? But let's just review systems of equations. Today we're going to talk about solving systems of equations in two variables by graphing. So, there's three different types of solutions to systems of equations. And we're going to look at the graphs of each type. So for the first one, we have one solution. Anyone recall what my solution is to a system of equations? My solution is an ordered pair. Because remember, we've got two variables, right? We've got to find our x value. We've also got to find our y value, so our answer becomes an ordered pair. Looking at it graphically, say I have that line right there. And let's say I have this line right there. What do you think my solution to this system of equations is?
Like the number?
Do what? Where they intersect, right? So whenever I'm solving by graphing, I graph my two lines on the same graph. Wherever they are intersecting, that is my solution to the system of equations. Does that make sense?
Can you draw that?
Yep. I would just draw two lines that are intersecting somewhere, and I'd put a point where they're intersecting, and that's how I know there's only one solution. Because they're only going to intersect at that one point, aren't they? They're not going to intersect anywhere else. I only have one solution. Put that away. Any questions on if I have one solution? If I have one solution, they're just going to intersect once. No solution.
Parallel.
Do what?
Parallel line.
They're going to be parallel lines. Very good. Because if the solution is where they intersect, but I don't have a solution, it means they're never going to intersect, correct?
Yeah.
So, say I have a line right here. And let's say I have a line right here. Those are parallel. So I know they're never going to intersect, correct? So that means I don't have a solution if they're never going to intersect. So you may want to make a note that says parallel lines. Do we remember anything special about parallel lines?
They're straight.
Besides they never intersect? Do we remember anything special about their slopes?
They're the same.
They're the same slope, right? So you may want to make that note as well. Same slopes. Any questions on no solution?
Isn't that like just like vertical? Or just say not two lines but one?
Say it again.
Isn't for infinite well,
We're not there yet. I'm just asking if there's any questions on no solution. Any questions there? Now we're getting to infinite solutions. What'd you say it was?
was that just one line?
Yes. So if I graph my first line and I graph my second line and it turns out to be the same exact line, They're intersecting at every single point on that line, right?
Right.
And those lines go on forever and ever and ever and ever and ever and ever and ever. So I have an infinite number of solutions. So infinite solutions. Does that make sense? Because once again, when we're solving by graphing, we're looking for the points at which they intersect. If they're intersecting everywhere, I'm not going to be able to list out every single solution because that's an infinite number I'd be writing for the rest of my life. So you may want to make a note that says same line. Okay, any questions about our types of solutions, our numbers of solutions? These are going to be the only three types you're going to have. One solution, no solution, or infinitely many solutions. Okay? We're good there? Okay. Number one on your piece of paper, we have y equals negative 5/3 x minus 6. Y equals 1/6 x plus 5. So what did we say we need to do first?
Graph lines.
Graph my lines on the same graph, right? So let's look at our first one, y equals negative 5/3 x minus 6. This is why I included those problems on our assignment yesterday where we were graphing the linear equations. Because what's going to be my best way to graph this right here? How do I get my points?
Graph the lines. And see where they connect.
How do I graph my first line, though? That's what I'm asking.
You start with -6.
What's negative 6 in this case?
The y-intercept.
Very good. So this is y equals negative 5/3 x minus 6. Our y-intercept we said was negative 6. So I put a point at negative 6 on my graph, on the y-axis. How do I get more points from there? Use my slope. I heard someone say it. Rise over run. If the negative is just in front of my fraction like that, does it go with my numerator? Does it go with my denominator? Does it go with both? Not both, because remember, if it went with both, a negative divided by a negative gives me a positive. But this is a negative number, right?
Maybe.
So does it matter if it goes with numerator or denominator? It does not. So where do y'all want to put it first? Yes.
Is that 5/3?
Yep, 5/3.
Oh.
Do you want to put it with the 5 first or the 3 first?
3.
3. So we have 5 over negative 3. So which two directions is this telling me to go?
Down.
Up how many? 5. And then left 3. Very good. Remember, my numerator is my vertical movement. So up and down. If it's a positive number, I'm going up. A negative number, I'm going down. My denominator is my horizontal movement. Positive, I'm going right. Negative, I'm going left. So we're going up 5, left 3. Do I start from the origin or my y-intercept?
Y-intercept.
Y-intercept. So from my y-intercept, I'm going up 5. 1, 2, 3, 4, 5. Left 3. 1, 2, 3. And I just keep doing that until I can't get any more points. I want you to get as many points on your graph as you can. Does everyone see that? If my graph was a little bigger, I could switch the signs of both my numerator and my denominator and get negative 5 over positive 3 and then go down 5 and right 3. Does everyone see that? Any questions so far? Now I just connect my line. Through all my points. Put your arrows on your line. There's my first line. Any questions how I got that? Now what do I need to do?
Move on.
Graph my second line. So on my second line, what's my y-intercept? Let's change colors here. Y-intercept is 5. And what's my slope? 1 over 6. So I put a point at 5 on my y-axis. And which two directions am I going to get more points? Up 1, right 6. Very good. Once again, start from your y-intercept. Go up 1, right 6. Put another point.
Lost count.
Once again, I can change the signs of both my numerator and my denominator. Get -1 over -6. And go which two directions now? Down 1, left 6. Connect the points with a line. Put your arrows on your line. Any questions about graphing our lines? We all good graphing? Okay. I've got to find the solution though. Raise your hand if you can tell me my solution here. Yes.
-6, 4.
Very good. Once again, it's this ordered pair right here. Where they're intersecting. Does everyone see that? So that'd be -6. Comma 4. And that would be my solution. Any questions on that? If I wanted to check my solution to see if it was correct, what would I need to do? If it ever asks you to check your solution, what do I need to do? To which equation? Both. Very good. I need to make sure it works for both of my equations. Because I do have some ordered pairs, like this one right here, is a solution of this equation, but not this equation. This point right here is a solution for this equation, but not this equation. So I got to make sure this point checks out for both of them. Does that make sense? So I'd plug -6 in for x, 4 in for y, see if I got a true statement out of both equations. Questions on that? Yes. Yes, you'd plug -6 in for x to both equations, then plug 4 in for y, and then work down both sides of each equation, see if you get a true statement or a false statement. Any other questions on number 1?
No.
Okay, I went through this one pretty slow and in detail. Are we okay if I move a little quickly through the next few?
Yes, sir.
Or do I need to go slow for anyone else? Are we not understanding anything? Okay, let's move on. Y equals 5, y equals 2x plus 7. Uh-oh. That looks a little different. How do I graph y equals 5?
Don't you split on y-axis, straight line?
Straight line? What do you mean by straight? All my lines that I've drawn so far are straight.
Take horizontal.
Well, it's horizontal. Very good. If I have just y equals a number, that means it's going to be a horizontal line. How do I know where it's going, though? It's crossing my y-axis. Where at? 5. Very good. So I can put a point at 5 on my y-axis. And then draw a line through it. A horizontal line.
Sunset.
Don't forget your arrows on your lines. Questions on the first one? Okay, second one. What's my slope and my y-intercept? 7 is what? Y-intercept. So I put a point at 7 on my y-axis. And what's my slope? 2 or what over what since we're dealing with slope? 2 over 1. Which two directions am I going? And how many units? Up to? Right one. Starting at my y-intercept. 1, 2, 1. Once again, I want you to get as many points as you can on your graph. That's all the points I can get going up. So if we change our signs, I can now go down to left one. There's all the points I can get. Now I can just draw a line through all of my points. Put your arrows on your line. So, what is my solution here? Sorry, my line's not completely on my dots. But where would they be intersecting?
-1, 5.
-1, comma, 5. Any confusion on where I'm getting the ordered pair, that is my answer. See that one right there. Questions on number 2? We okay? All right. Number 3. Number 3, we have 6x minus 5y equals -45. And then we have 2x plus 2y equals -4. Is this are either of these in slope-intercept form? No, they're not. So what do you think I'm going to have to do?
Put it in their slope-intercept form.
Huh?
Subtract 6x.
I'm going to have to do what, essentially?
Solve it.
Solve it for
Y or something.
y. I'm trying to get y by itself, right? So I got to do a little work before I can start graphing. So what would we say my first step was? What would we say my first step was?
Just subtract 6x.
Subtract 6x from both sides. So I get -5y equals. Can I combine -6x and -45?
No.
No, so I leave it as -6x minus 45. What's my last step here?
Divide by 5.
Divide by 5 on both sides. Positive or -5?
Positive.
-5. If I divide my right side by -5, each term has to get divided by that number. So everyone see that? Shh. Questions there? A negative divided by a negative gives me a positive. Do I want to convert 6 over 5 to a decimal? No, why?
Because it will mess it up.
You can.
But
Because it's already in slope-intercept form.
What is this whenever it's in slope-intercept form?
That's the rise over run thing.
That's my slope, right? Slope, I just want to leave it as a fraction. That way I can do my rise over run. So it'll be 6 over 5. X. -45 divided by -5. 9. Everyone good with that? Now, is that in slope-intercept form? Yes, it is. What is my y-intercept? 9. Put a point at 9 on my y-axis. What's my slope? 6 over 5. Up 6, right 5. Can I go up 6, right 5 without going off my graph?
No.
Nope. So what two directions do I need to go?
Down 6, left 5.
Down 6, left 5. Just like what it was right here. Negative 6 over negative 5. So down 6, left 5. Down 6 again. Left 5. Connect my points. Put your arrow on your line. Everyone good solving those for y? So did someone already solve my second equation for y? Or no? Do we need to do it real quick? Let's do it real quick. What's my first step there?
You have to
Subtract 2x. We get 2y equals negative 2x minus 4. And then what do I do? Divide by 2 on both sides. Negative 2 divided by 2? Negative 1 or just negative x. And then negative 4 divided by 2? Negative 2. Questions there? What's my y-intercept? Negative 2. And what's my slope? Negative 1 or negative 1 over 1. So I'm going down 1, right 1. Get a lot of points here. I can also go up 1, left 1. A lot of points on this line. Questions how I got either line? What is my answer here? Can someone raise your hand and give it to me? Negative 5, comma 3. Very good. That would be my answer. It's the ordered pair where they are intersecting. Right there. Questions on 3? We okay with these? Pretty simple. Graph the lines, see where they intersect. That's my solution. Okay? Number 4. What do 5 and 6 look like? Okay. Let's get these knocked out real quick. Number 4. How could I graph the first one without getting slope-intercept form? We did problems like this on day 1 assignment where they were not in slope-intercept form, but we graphed using the
It's because X and Y are on the same side.
X and Y on the same side.
Should mark one out.
cover
What are those called though? What am I finding? X and Y intercepts. Very good. I can graph this using my X and Y intercepts. So covering up my Y value, what do I get after I cover up my Y? 3x equals negative 12. And so what does x equal?
Negative 4.
X equals negative 4. That's my x-intercept. So I put a point at negative 4 on my x-axis. To find my y-intercept, I cover up my x term. What am I left with after I cover up x? What?
6y equals
6y equals negative 12. So what does y equal? Negative 2. So I put a point at negative 2 on my y-axis. And there is my y-intercept. Any questions there? All right. Got to connect the points. Put my arrows on my line. You guys remember that from the day one assignment? You can graph that way if you'd like to, but once again, I would use that little trick only if x and y are on the same side. What's going to be the easiest way to graph the second equation? What do you mean just do it? How do I just do it?
Go to negative 4.
Using the what and the what? The y-intercept and the slope. Very good.
That's what I said.
So what's my y-intercept?
Negative 5.
Negative 5. What's my slope? Negative 1 over 2. So I'm going to go down 1, right 2. Do what? Or I can go up 1, left 2. Connect my points. What kind of lines are these? Parallel. Are they ever going to intersect?
No.
No, so what's my answer?
No solution.
No solution. You can write out no solution,
Or NS.
or you can use the no solution symbol, which is a circle with a slash through it. Questions on 4? If I were to solve my top equation for y, I would have gotten a line that had a slope of negative 1/2. I could have said that there was no solution without even graphing it at that point, because I know they have the same slope. Okay? Questions on 4? Number 5. Let's go ahead and solve both of these for y. First equation, what's the only thing I have to do to solve for y?
Divide by 2.
Divide by 2. I'm dividing everything by 2. 8 divided by 2?
4.
18 divided by 2.
9.
Am I moving too fast for anybody? Okay, that one's already in slope-intercept form. Y-intercept is? 9. Slope? 4 over 1. So up 4, right 1, or in this case, I'm going to go down 4, left 1. Okay, what do I need to do to solve for y on my second equation? What?
Subtract 24.
Subtract 24 from both sides. or y equals x minus 24. Next step, divide by 4. So I get y equals 1/4 x minus 6. What's my y-intercept?
-6.
-6. What's my slope? What? 1/4. Up 1, right 4. Down 1, left 4. So raise your hand if you can give me my solution.
-4, -7.
-4, -7. Very good. Once again, the ordered pair where they are intersecting. Right there. -4, -7. Questions on that? We got one more example. Can I move on to the last one?
Yeah.
All right.
Alright.
All right. Solve each of these for y. How do I get y by itself on the top equation?
You gotta do
By -1. Very good. So I'm dividing everything by -1. So I get y equals x plus 6. How do I get the bottom equation? Actually, let's graph this one real quick. What's my y-intercept? 6. Slope?
1/1.
Up 1, right 1. Down 1, left 1. Okay, second one. What do I need to do to get y by itself? Divide by 3 all the way around. So I get y equals 1x plus 6. What happens here?
Oh my.
Wow.
They are the same.
It's the same line. Would you look at that?
Infinity.
What?
So if I graph this line again, it's just going to be the same exact line, right?
That's correct.
What is infinity?
So, what is my answer here?
Infinity.
Not infinity.
Infinite solution.
Just say infinite solutions or infinitely many solutions.
Infinity. Yeah. Can I just draw an infinity?
Nope. Because infinity is not my answer.
Leave.
Infinity with the solutions under it.
So we can write infinity.
Just put infinite solutions.
Can I write the infinite sign and then solutions?
I'll just write it out. You'll be good. You'll be good. So I'd say infinite solutions. I'm not going to write down every single ordered pair. Once again, that'd take me forever. Questions there? We okay solving systems in 2 variables by graphing?
I need more words.
Okay.
You said
We ready for the assignment?
Yes, we are.
Any questions before I end my recording?
No. Go ahead.